Hello everyone, we're in group 2 in Geostatistics subject. So the topic today is about how to determine the facies with geostatistic techniques. In my presentation, it will got a lot of parts to discuss. So now let's turn to the first part. What is facies? So, facies is a body of rock characteristic by a particular combination of literary, physical, and biological structures that bestow an aspect that different from the bodies of rock above, below, and laterally attraction. The facies concept refers to the sum of characteristics of a sediment unit, commonly at a fairly small centimeter to meter scale, including literary, grain size, sediment structure, color, composition, and biogenetic content. So, the figure here, every depositional environment put it all distinctive imprint on the sediment, making a particular facies. Thus, a facies is a distinct kind of rock for that area or environment. Sandstone facies here usually appear in a beach, shallow marine environment, and shell facies in offshore marine environment. And the last one, limestone facies is far from the sources of terrestrial input or maybe in a deep sea. So we got a technique to determine the facies by geostatistics. So the first technique, 3D seismic data. It contains a field of brackish in deep water turbidite environment, within a excessive cost associated to deep water drilling where data is limited. So 3D seismic data is a very good to excellent quality, is a key driver for reservoir characterization and picking geological bodies and architectures. The architecture are essential elements that in turn try the facies and physical modeling workflow. With high quality 3D seismic data, volume attributes can be used to attempt a quantitative prediction of facies, heterogeneity, or porosity distribution within the reservoir. The present study developed a method for enhanced conditioning of geostatistical facies modeling to seismic attributes. Thus, the combining techniques for better representation of reservoir heterogeneities, conceptual phases of development, and available static data including one well, 3D seismic data, and various seismic inversion cubic. At the figure 1 here, the reservoir unit under consideration consists of wide deep water channel Levy complex, itself containing several erosive, constructive, unitary state channels. Multiple point statistics. Seismic conditioning of the facies model is facilitated through the use of multiple point statistics. This geostatistical facies model technique enables to reproduce complex sedimentary geometries while allowing easy conditioning by both hard and soft data. The outcome of this work is the set of facies model accounting for the geological uncertainties involved, and the specific efforts it makes for the data integration. Volumetric characteristics derived from well testing were used to evaluate the facies model. Multiple point statistics is a statistical technique that combines the advantages good shape, reproduction, and easy data conditioning. Its work basic principle is based on the use of training image, which is the conceptual model of the sedimentary architecture expected in the reservoir. Sedimentary pattern represented in the training image at various scales are reproduced in the reservoir grid during a starting. simulation process. So, what is training image? Training image is conceptual modeling sedimentological heterogeneities of the reservoir. This corresponds to the sedimentologist's view of the sedimentary architecture expected in reservoir. The training image concept is powerful in that the heterogeneities model is much more intuitive than those provided by VARAM. It also carries much more information about multi-point instead of two-point statistics. In practice, the training image is 3D regular independent of the reservoir, filled with the facies value representing heterogeneities at the rig resolution. The scale of training image rig must be the same as that the reservoir rig. High resolution seismic data. In case where the seismic training of analog environment is of very good quality and accurate, the positional model can be constructed and used either as a 2D or 3D training image. So, the figure 2 here is illustration of multiple point statistic method, direct sampling algorithm. So in this reservoir rig, the neighborhood of the cell to be simulated within the question mark is analyzed and pattern is defined in this number 1. The training image is scanned for the considered pattern, and then once the pattern has been identified in the training image, this number 2 here, the concentrol value is recovered to the number 3, and then it passes into the reservoir rig at the simulated location, number 4 here. So, why we should use a multiple point statistic? So I think multiple point statistics is very useful to determine the facies. Multiple point statistics has the advantages of allowing geological, consistent representation of sedimentary body combined with the effective integration of hard and soft data. Firstly, in terms of geological realism, multiple point statistics reproduce the pattern depicted in the training image. If the training image is good quality and adequate parameters are chosen, reproduction is satisfactory. Secondly, regarding the data integration, multiple point statistics allow the integration of both hard and soft data. The simulation start and propagate around the hard data, ensuring realistic facies arrangement around well. Like most of the other pixel-based techniques, the integration of soft data is also transformed. Other algorithms, such as abstract basis technique, to producing geological realistic model, fail in the integrating an important amount of secondary data, as the major stake here consists in producing geologically consistent facies model that accurately integrated secondary data derived from seismic information. Multiple point statistics to be the most adequate method. So, in conclusion, the global statistics consists of deriving a curve of sand proportions from seismic attribute and using these proportions to control the facies models. Conditioning was facilitated through the use of multiple point statistics facies simulation, which allow easy integration of secondary data in the model. Second one, in this work, new methodology was proposed to condition reservoir facies modeling to seismic attribute data. In the case where well data is particularly spread, this technique was designed to integrate the seismic constraint in the multiple point statistical simulation with direct sampling. So at this technique, which rely on the main training image, can integrate the auxiliary training image to better constrain the modeling process. The key idea was to generate a sand proportion auxiliary. So here's some references we used to the presentation. So if you can search this on one picture and on the other research. Thank you for listening. I'm very grateful if you got any question.